Hi everyone. Today we're going to study how to find the domain of the function. So this is finding domains of functions. Letter A. If function written in an equation form, this is what we will do. First, identify the input values. Second, identify any restrictions on the input and exclude those values from the domain. And last, write the domain in interval form if possible. Let's have example. Find the domain of f of x equals 2x squared plus 5x minus 3. The question here is, what are the numbers that we can substitute for x? We can think of many numbers. One example is 0. We can use 0 to replace the x in the function. If we do that, the value f of x will be -3. We can think of other numbers like 1 or -10 or 50 or 100. We can think of many numbers that can replace the x. If you notice, our function here is a polynomial function, and the domain of the polynomial function is all real numbers. So it means the domain here is all real numbers, and in symbol we can use r, or in interval notation this is equivalent to -infinity, infinity. This is the interval notation for all real numbers. This is our final answer. Let's have letter B. If function written in an equation form that includes a fraction. This is what we will do. Identify the input values. Identify any restrictions on the input. If there is a denominator in the function's formula, set the denominator equal to 0 and solve for x. Last, write the domain in interval form, making sure to exclude any restricted values from the domain. Let's have example. Find the domain of f of x equals the fraction where numerator is 5 minus 2m all over the denominator m squared minus 9. Actually, we can think of all real numbers as the domain of this function. However, since we know that the denominator should not be equal to 0, our goal now is to find the value of m when the denominator is 0, then exclude in the domain. So what we'll do, we will write the denominator here, and then we will equate this into 0. After that, we will solve for m. So our equation here is m squared minus 9 equals 0. We will use factoring to find the value of m. This m squared minus 9 is factored out into m plus 3 times m minus 3. And then each factor we will equate to 0. So the m plus 3 equals 0. The second factor, m minus 3, is also equal to 0. Then we will solve for m respectively. So in here, the positive 3 we will transpose on the right side. We will have m equals negative 3. On the other factor, m minus 3 equals 0. Transposing this negative 3 on the right side, we have m equals positive 3. So we have now two values for m. The first is negative 3. The second is positive 3. Again, we look for these values of m because these values will make the denominator equal to 0, and we will make sure that we will exclude these values in the domain. So in writing the domain, we will write all real numbers except 3 and negative 3. In symbol, we can write like this: R to represent all real numbers, then minus the values 3, negative 3 inside brackets. This is our final answer. Let's have this type if function written in an equation form including an even root. It means we have a radical with an even numbered index. So we will first identify the input values. Next, since there is an even root, exclude any real numbers that result in a negative number in the radicand. Set the radicand greater than or equal to 0 and solve for x. The solution or solutions are the domain of the function. If possible, write the answer in interval form. Let's have example. Find the domain of f of x equals the square root of the quantity 7 minus x. Please note that for radicals with even root or index, radicand cannot be a negative value. Radicand means those terms inside the radical symbol. And in here, in our problem, the index is 2. So what we'll do now is to copy the radicand, that is the 7 minus x, and then we will write greater or equal to 0 because we say that this radicand cannot be equal to 0. So we will always use the symbol greater than or equal. And from here, we will solve for x. We want this x to be alone. We're going to remove the 7 here. So we will add a negative 7 to both sides of the inequality. So we have here plus negative 7, and on the right side also plus negative 7. And this 7 plus negative 7 will cancel each other. We will have now negative x greater than or equal to negative 7. We want the x to be positive, so we're going to multiply the inequality by negative 1. We know the rule for inequality that when we multiply by a negative number, the inequality sign reverses. So it will be positive x now less than or equal to positive 7. Now, just to illustrate, we're going to put this in the number line. So here is the positive 7. So x less than or equal to positive 7. It means those numbers on the left side of this positive 7. So this is our graph. And we put a solid dot on top of 7 because of the less than or equal sign. It means the number 7 itself is part of the solution. So for the domain, we will write negative infinity. Of course, we use a parenthesis here, comma. The endpoint is the positive 7, and we use the square bracket to denote that 7 is part of the solution. This is our final answer. I hope you learned something from this video. See you again next time.